All right, well, as I'm recording, here we go. This is Algebra 2 Honors final review packet. We're on Chapter 5, trigonometric functions. Okay, we have two ways to measure angles. We have radians, we have degrees. Radians, we think about the perimeter or the circumference of a circle being what length? It's 2 pi. I think a good way to think about radians is that you're writing your angle as a fraction of that. So when we talk about like a quarter of 2 pi, that's pi over 2, right? That's the theta. When we are working in degrees, we're working out of a fraction. We're thinking about the circumference is 360 degrees, and so we're writing as almost like a fraction of 360. So this is a quarter would be 90 degrees. Okay, to convert from radians to degrees, what do we do? If I'm going from radians to degrees, I multiply by what value?
180 over pi.
180 over pi. To go from degrees to radians, you multiply by pi over 180. Okay. Coterminal. Angles are coterminal if what? What is true about them? If they're coterminal, they
have different measures, but they're like equivalent or in the same place.
Exactly right. So if you imagine like 270 degrees, right? 270 degrees. What would be a coterminal angle to 270 degrees? Negative 90 is coterminal, right? So what we can do is take that theta and plus or minus 360 degrees times, okay? And that will give you a coterminal. And if it's written in radians, it's that theta plus or minus 2 pi k. So if you do a full rotation, you have a coterminal angle. Arc length. And arc length, S, is equal to the theta times the radius. But the theta must be in radians. So S equals theta r, but theta must be in radians. Area of a circular sector is theta over 2 times r squared. Again, theta must be in radians. Okay. Trig ratios. We have 6 trig ratios. They are sine, cosine, tangent, cosecant, secant, cotangent. Sine is what ratio? Opposite over hypotenuse. Cosecant is the reciprocal, so hypotenuse over opposite. Cosine theta is adjacent over hypotenuse. Secant is the reciprocal, hypotenuse over adjacent. Tan is opposite over adjacent. Cotangent is the reciprocal, adjacent over opposite. Okay, are we okay on that? It's pretty familiar. We have some special triangles, and these are like, once you know the unit circle, I think these aren't as relevant. Although like the unit circle comes from these triangles, right? So if we have a 45, 45, 90 triangle, what are the side lengths or ratios of the side lengths of this? So these two side lengths are 1 or a, right? You can think of them as some a, and then the hypotenuse is root 2a, right? And if we have a 30, 60, 90, this is 60, this is 30, what is the relationship here? You remember? The hypotenuse is 2a, good. This short side is just a, and then the long leg is root 3a, good. Okay. All right, those are the special triangles. I'll give you a second. Okay, turn the page.
Root 3 times a, right?
Yeah. We have area of the triangle. There's two formulas for the area of a triangle. We have two situations. We have SAS, where we have two side lengths, let's say A and B, and we have the angle between them. Let's call that big C. So if I want to find the area of this triangle, we can use the formula 1/2 AB sine C, right? So that's the sine of the angle between them. For herons, we need a value before we use herons, and that's the S. Remember what S is? It's the semi-perimeter, right? It's A plus B plus C. It's all the side lengths added up divided by 2. This would be a case where you have all the side lengths but no angles. And then our formula is area is the square root of S, and then the difference between S and all the side lengths. So S minus A, S minus B, and then S minus C. Okay? All right. Find value of 6 trig functions when cosine theta equals 7/12 and sine theta is negative. So where do you begin with these problems? You're given cosine and you're told that sine theta is negative. You want to start by drawing the axis and like figuring out which quadrant we're in. If sine is theta but sine is negative but cosine is positive, which quadrant are we in? So we're on quadrant 4, right? Because sine is negative, so I must be in the lower half, but cosine's positive, so it's got to be here. And we can draw out our triangle. So adjacent side would be 7. We don't know the opposite side, but we do know the hypotenuse has to be 12. So this is 12, this is 7. To get all the trig functions, we need to have all the side lengths. How do we find that missing side length? Pythagorean theorem. So we'd say that 144 equals 49 plus c squared, or b squared, whatever variable you want to use. And that, what does that come out to? Is that 95 equals b squared? Is that right?
95, yep.
95 equals b squared. So that b must be root 95. Okay, so this is root 95. Can we then write out the 6 trig functions? Go ahead and take a second to write out the 6 trig functions. Yeah. We got it? Sine would be what? Root 95 over 12. And then this would be, when you rationalize, it'll be 12.
Root 95.
over 95.
Yeah.
Cosine, we're given 7 over 12. Secant must be 12 over 7. And then tangent, root 95 over 7. And then 7 root 95 over 95. Okay. Inverse trig functions. Okay, so for each trig function, there's an inverse, and we can say either sort of it's signed to the -1 of theta, or what's the word we can use? Arcsine. So we have arcsine. We have same thing for cosine. And tangent. So if you remember, the ranges vary based on the function so that we only get one output. Do you remember this a little bit?
Yeah.
So the range for inverse sine is from negative pi over 2 to pi over 2. The range for inverse cosine is from 0 to pi. And then for tangent, it is same as sine.
Is it different, like the bracket versus the parentheses? Like,
Yes. Sorry, we should have brackets. But for tangent, it's parentheses. Yeah, my bad. Okay. These are closed because those values exist for arcsine and arccosine, but for arctangent we have asymptotes, so we can't do that. So that's why those are open. So how does it work for inverse sine? So you put in, what do you put in for inverse? You put in the ratio, so something like 1/2, and we get out an angle. So what if I took inverse sine of 1/2? I would get 30 degrees. Okay. Law of sines. Law of sines. Do we remember this one a little bit? If we have a triangle, A, B, C, and angles big C, big B, and big A, the law of sines says that sine A over little a is equal to sine big B over little b equals sine big C over little c. Or you can write little a over sine A equals little b over sine B equals little c over sine C. Does this ring a bell a little bit?
Yeah.
So we use this to solve triangles. Law of cosines we use when we have we already have like an angle on the opposite side. So let's say we knew that this was A, this was B, and this was big C, and then we wanted to know what this was over here, right? This is little c. That formula is little c equals root a squared plus b squared minus 2ab cosine big C. Got it? So these help you solve triangles. I'm going to turn the page over. Can I do it? Or I'll give you that. Okay. Yep. Solving triangles. So let's do like a couple examples just to refresh your memory. Let's say you knew that you had a triangle and you knew this side length was 2, and you knew that this was 129 degrees, and you knew that this was 23 degrees. Okay. When you have angle, angle, side, which rule are you going to use to solve this triangle? You're going to use the law of sines. because I have a pair, right? I have an angle and I have the opposite side. If you have that, you can solve the whole thing. Okay? Do you guys want to try, or do you want me to do it with you? Okay, go ahead and try. I'm going to give you 2 problems. So that's going to be a law of sines one, and then I'm going to give you a law of cosines one.
I have a calculator. Oh, 28. Sine 23 to sine 129.
Kelly, 129.
Yeah.
Any mushroom? 2.
Yeah, I'm going to pause the video. Sine 23 over 2 equals sine 129 over, let's call this x right here. Okay, so we're just going to get x alone. So we would get x equals 2 times sine 129 over sine 23. That would be the value of x. Does that make sense?
Yeah.
And so like on the test, either these would be like sine 30, sine 60, you know, these would be values that you know, or you would just leave it in this form. But you wouldn't be expected to evaluate like from a,
That all divided by
yeah,
8.
this is fine, is what I'm saying. Does that make sense? Okay, are we good on the first one, for solving for those sides? Okay. The second one, what do we use here? Law of cosines.
Do you do the law?
So we'd say that this side length here, let's call it x. X equals root 1.4 squared plus 2.3 squared minus 2 times 1.4 times 2.3 times cosine 58. Okay. And all of this together, what do we get? Has anybody done it?
2.
You got 2?
Yeah. How would you get 22? Just look at the other numbers.
Yeah, what?
Side it's 2.3, not 25.
What is it? 2?
What do we get?
22.
22.
What?
I can't believe you actually
No,
wrote that down.
it's 1.95 or 2.
Okay, 1.9.
I
Okay.
wrote down
Yeah.
23 instead of 2.
Or 96, but yeah.
All right.
9, 6?
All right.
I took 2.
Yeah, how do we solve the A?
So then once you have this side, then you can use what?
Law of sine.
Okay. Then use law of sines. Good.
Wait, are we doing chapter 6?
I'm gonna stop the video here so I can save this gem.